Hey friends, welcome back to BIMvoice. My name is Petru, and today I have the pleasure to talk to Wassim Jabi, who is a professor and chair of computational methods in architecture at the Cardiff University. And today we are going to talk about Topologic, one of his projects. Hello Wassim, how are you doing?
Good. Thank you.
It is very nice to have you here. Let's start by telling us a bit about yourself with your own words.
Sure. I'm an architectural professor. I graduated from the American University of Beirut with an undergraduate degree, then immigrated to the US and got my master's and PhD from the University of Michigan and worked in the US for a few years. And then we moved to Cardiff University, the World School of Architecture. I've been there now for 14 years almost, where I am leading the computational methods research group. I assume you want to talk about Topologic. I'll save you some time and tell you a little bit about Topologic and how it started. Basically, I have been working on connecting conceptual design to energy analysis. That was how I started when I came to the World School of Architecture in Cardiff University. And I met Professor Robert Aish, who was with Bentley and then Autodesk and then with UCL at the Bartlett. And he was talking about non-manifold topology, a mathematical concept that I knew nothing about at that time. And he mentioned that non-manifold topology is also compatible with energy analysis. So that kind of, lit the bulb, and I thought, let me investigate that a little bit more. So I started understanding what non-manifold topology is and spoke to Robert a little bit more about it. And it was something that was available in Dynamo for Revit. Early versions, not in Dynamo, but the design script actually. But when they moved it to Dynamo, that capability was not available anymore. They took it out. So I talked to Robert Aish and I said, let's write a research proposal that will bring back non-manifold topology into Dynamo, and we do it in an open source and a more comprehensive way. We write a full API, around it. He agreed, and we wrote a proposal to the Leverhulme Trust, and thankfully they funded us. And that was in 2016. So they funded us for £300,000, and we spent 3 years with a team to create what ended up being Topologic. So that's where it came from. Now, since the project ended in 2019, I have been working on it mainly on my own with some help from some friends. And we are expanding it and bringing it to different platforms and really increasing its robustness and versatility.
That sounds very good. If you have some slides or something that can make this easier digestible.
No, absolutely, yes.
Before you start actually talking about your slides, I have another question, a more basic question. I'm a civil engineer. I don't know much about energy analysis. What does that mean actually? Because that's something that architects do, right? Maybe other professionals are not really aware about this. What is the real problem and how does this help the entire industry?
Well, actually, energy analysis is usually done more by engineers than architects, but engineers who are trying to predict and analyze the energy performance of a building. And they help the architects by providing information about that, like cooling loads or heating loads or annual energy use. So they're trying to analyze what the decisions made by architects are going to cause in terms of energy performance. And obviously that's very important in the current climate crisis that we have and issues of sustainability.
Yeah, I understand. Pardon me, because I worked mostly with concrete in my life. So
okay. Yeah. So let me introduce Topologic for you. As I said, from 2016 to 2019, we had a team from Cardiff University at UCL that worked on it, and we were funded by the Leverhulme Trust. So these are my partners in crime. Robert is now, I believe, retired or semi-retired. Simon is still with us. Katerina and Nicholas were our research associates, and Katerina is now a lecturer with us. She stayed with us at the school, and Nicholas has moved to Japan, I believe. So the issue that we wanted to address is we looked at how BIM software has been developing, building information modeling, and we found out that while it is very useful for quantifying and modeling components, it had some problems. And the main problem it had is that it is unstructured and unconnected and ad hoc. What does that mean? That means that it is almost like a display list of what is included in a building, but these elements are not normally connected to each other. So you cannot, for example, get a wall and say, what floor are you connected to, or what room are you part of? Sometimes you can, sometimes you cannot. And so that's why it is ad hoc. And we thought that this causes a lot of problems because then as a software developer or somebody who's trying to use this data, you need to write ad hoc methods to compensate for the lack of connectivity in the database. And we thought that's just a really bad way of going about it. And we set out to create a system that has connectivity and information part of its DNA, embedded in it from the beginning. So we wanted to redefine BIM using geometry, topology, and information. Those are the kind of three foundations for topology. So obviously we wanted something that will create geometry. We cannot get away from geometry. We need to model 3D spaces, but those 3D spaces are always topologically connected. What do I mean by that? That means that you can take any space, like say a cell that you see or a room that you see in this building, and you can ask it what other rooms are connected to it. That information is always available. It's part of the data structures that we built. So you don't have to do extra work. You can just simply say, given room A, what other rooms are connected to it. But also you can take two rooms in a building, any two rooms, room A and room B, and say, do you share any faces between each one of you? Are there any shared walls? Are there any shared edges? And that kind of information is also always available, and that can become really useful when you're trying to analyze your project.
Yeah, one more simple question. What does topology mean? What is topology?
Topology is how things are connected to each other. And when we're talking about topology within geometry, it is the features of an object that do not change when an object is transformed. Meaning that, for example, I can take a cube. Imagine like I have a cube. I can distort it, right? I can stretch it. I can make it longer. I can distort it. But how the vertices are connected to each other and how the faces are connected to each other stays constant. It is whatever stays constant in the face of geometric change, how things are connected.
Yes, that makes sense now.
So you see here in the images, you can start get a hint about what's going on with Topologic is that behind the scenes, and sometimes we make it visible, but behind the scenes, there is a graph, and the graph is nothing more than a set of edges and vertices that are connected. There is a graph that represents the connectivity of this building. And you can see it here in those wireframe images that you have there. And because we have a graph, we can go out to graph databases like Neo4j, and we can do graph analysis, graph theory analysis. So the solution is made out of these three steps. We would like architects and consultants and engineers to start designing a succinct but semantically rich conceptual model before they start designing a BIM model that is very complex. Start designing these simple models that are succinct, but they are full of information. You can take these models and you can analyze them a lot. You can get a lot of information out of them even before you transform them into BIM models. You can do energy analysis, you can do multi-objective optimization, you can look at the parts, how they are connected, you can do computation on them in many different ways. And once you are satisfied with that, you can use this conceptual model now with the information that's embedded in it to allow software to automatically and intelligently convert it into fully detailed BIM models. And we believe that in the future, humans are not going to be the ones creating or populating BIM models. It will be software. And software, I think, based on rules and shaped grammars, will be a lot more accurate in populating BIM software. And that will free architects to design the strategy for the design rather than be, encumbered with wall thicknesses and, furniture, populating the BIM model with furniture, etc.
Yeah, that makes sense. Focusing on the value, not on repetitive tasks that can be easily done by algorithms at some point, yes.
100%. So one really good use case scenario that we're very proud with Topologic is the work that Ahmed Al-Tahlawi has been doing at ePro Consult. Ahmed and I met up, I think now it's been about 2 years ago, and we have been collaborating very closely, completely informally, not under any kind of funding or anything like that. I've been helping him with his work, and he introduced Topologic to his company, which is ePro Consult in Germany, and they have put it to really good use. Here I'm showing an example of that. This is just the tip of the iceberg. Basically, they had a problem where their BIM models had a lot of rooms, and these could be hundreds of rooms, but they are not grouped into apartments. So in order to calculate, let's say, rentable space and figure out how many apartments you have and where they're located, etc., you need to categorize these rooms into apartments. Currently, what he told me is that an architect, probably a junior architect, will sit down and click on every room and then tag it and make sure that they are all tagged the same way. And any one mistake he will have to redo. And these could be hundreds and hundreds of rooms. So we use Topologic to derive all these rooms, build a graph, find what we call graph islands. Those are, subgraphs that are isolated from other graphs. Mm-hmm. And we know that those graph islands make an apartment. So we take the spaces that are in this graph island and we group them automatically, and we send all that information back to Revit. So all of a sudden you get color coding, you get everything categorized correctly, and he generates all the needed reports. And the building now goes from just a conglomerate of individual spaces to hierarchically organized set of apartments. Mm-hmm. You can do that for hundreds and hundreds of apartments.
I see. You mentioned Revit right here. So this makes me believe this is not a standalone application, and it's a plugin that integrates with other solutions, right? Am I right about this, or did I understand it wrong?
Half right. Topologic is written in C++ and has Python bindings. So Topologic is basically, you can think of it as an API or a foundational piece of software. You can access it from different plugins from different ways. You can access it even from a command line. You can open up a Python shell and start typing Topologic, import Topologic, and you can start typing Topologic. But what we have done is we've created several interfaces to Topologic. One is a Dynamo plugin, and that's why it connects to Revit. One is a Grasshopper plugin. Another one is a Blender Spherchalk plugin. Now I'm writing one for FreeCAD. And you can, as I said, access it from any Python module.
Yeah, I understand. But I think I looked a bit into how you can integrate this with Spherchalk and Blender BIM. And I think so it was quite complex, the installation and everything. Do you have any plans, or are you working on making this more user-friendly?
I think you have looked at it many, many months ago. Right now, it's a one-click install.
Okay.
It's very, very simple. You download the zip file, you don't unzip it. You go to Edit Preferences, you install it one click, and you activate it. So Topologic is now installable in Blender Spherchalk, exactly like Blender BIM, exactly like other add-ons.
Awesome. Yeah. That's very good. And something else very important to highlight here. This is open source, right?
Correct. Always 100% free forever.
And free, not only open source, because it's free open source.
Free open source. What we mean by, it is free right now. Obviously, we don't charge money for it.
Yeah.
That's what most people think when they think about free, they think about money.
Yeah.
In the open source community, when we talk about free, we mean free to use. Meaning once you download the software, it's yours. You are free to do with it whatever you want. Topologic has some restrictions for commercial applications. It is under an AGPL version 3 license. What does that mean? It means that you can use it as much as you want, but you cannot bundle it with closed software and sell it. It's just protected from somebody taking our work and selling it.
That makes sense. But
for you as a company, you can install it and not owe Cardiff University or UCL a dime. You can just install it on thousands of seats and just use it as you wish. There's absolutely no restriction.
Can you also contribute to it? If you develop something on top, you can ship it to the main library, right? Or to the main API.
Yeah, Topologic is on GitHub. There have been a few people who have contributed to the code, not many, I must say. But also, if you look at Homemaker by Bruno Possel, he took Topologic and used it as a base and built his software on top of it, and then provided all of that as open source to Blender. Basically, Topologic objects and makes them into IFC objects. I have another person, Andrea, who did something called BIM to BEM, where he takes IFC objects and builds energy models ready for energy analysis using Topologic as well, and IFC.
Interesting. But how does this go with IFC? Isn't this something you could have integrated with the IFC schema, or what is the relationship between IFC and Topologic, for example?
Sure. Topologic uses an engine called OpenCascade. When we designed Topologic, we did not really look at IFC in particular. We needed just simply the basic geometry kernel or geometry engine to create those non-manifold topologies. What we found out though is that Topologic geometries allow you, and because it has topology and because it has information, somebody could very easily take a look at that conceptual model and then use it as a skeleton to build IFC entities on top of it. Very similar to the way we have taken test fit conceptual models, made them into topologic models, and then we wrote a transformer that takes those topologic models and makes them into Revit models by thickening the faces, looking at the topology and adding the correct BIM details. Bruno Postel has done the same thing with Homemaker, where he is looking at how the cell complex, it's called the cell complex, the topologic object, how it is formed, and thickening it and adding the correct IFC components, and he builds a completely industry standard IFC model out of it, using IFC OpenShell and Blender BIM, calls, using the API. So that's how we are dealing with IFC right now, is that topologic models simply can be transformed into fully detailed IFC models. However, something we probably can do in the future, one thing that people perhaps don't know much about, is that IFC has something called an IFC graph, which is also talks about how things are connected. And I could imagine in the future, Topologic could be based on IFC and leverage the IFC graph to maintain that topological relationship between entities. Right now, we have our own data structures for that based on Open Cascade.
All right, I understand.
Okay.
That sounds very good, actually. Yeah.
So again, if somebody is trying to decide whether to use Topologic or not, Topologic is unique. I haven't really found many competitors for it that do the same thing. There is some concepts that are implemented in GIS in terms of topology, obviously, but not quite the way Topologic works. It's versatile. It has been applied to conceptual design, pathfinding, BIM, energy analysis, blockchain, and machine learning. I'll show you some examples of that. And it's universal. It's written in C++ underneath, but it has Python binding, so it's very easy to use. And it has been used on a 20 million euro project by eProConsult, which is under construction. So they trusted it to optimize the design and convert it into a BIM model that then they developed further for construction.
That's impressive.
It is. I was really, I was impressed by that. I was really happy to see that they have used it. So this is the project that's being built right now. This is from eProConsult, from Ahmed. And this is the, a conceptual model of it, of rooms, etc. And you can see how there is a graph. This is the yellow lines that you see there. And the red is the apertures, what we call apertures, which is doors and windows. And so everything is connected. And you can also traverse them. You can say, how do I get from room 1 to room 2? And only travel through doors, etc., etc. So all that information and connectivity is available.
This looks like a graphical database, or what about linked data?
Instead of linked data, relational databases where fields are pointers to other fields, we decided to focus on, graphs, and we connect to graph databases like Neo4j. We think it is a more appropriate, more useful representation of the objects that we are creating.
All right.
So these are three main case scenarios. On the left is one of the early work that we have done with Ahmed, which is to take test fit models. These are created by testfit.io. Take all that information, connect them, and also put the information in them. So you know which one is a unit, which one is a corridor, which one is a parking. So that's what the color coding is about. So that is always part of the geometry, like it's inside the topologic entities. So you see all these models. In the middle is Homemaker by Bruno Postel. This is the topologic to IFC. So it allows you to create a very simple, let's say, cuboid shape, put some faces, some planes to intersect it, and just that. And then with one click, you get that building that you see in the lower corner.
Wow.
fully IFC compliant, all the windows are detailed, cornices and details are in there.
I need to try this, and I hope I'll get Bruno on my podcast.
Absolutely. He's fantastic. He's absolutely fantastic.
Yeah.
And on the right is the current work. This is cutting edge work that we're doing now with PhD students here at Cardiff, which is, again, taking labeled graphs of a synthetic database and applying graph machine learning to understand what we are looking at, to understand the category of that graph. And in this case, this particular example is looking at how a building meets the ground, the relationship between building and ground. Is it hovering? Is it interlocking? Is it kind of adhering to it, etc.? And we have achieved, just very recently, we have been able to achieve close to 98% accuracy on unseen data.
Wow.
Very, very accurate. So this is literally from, maybe yesterday or day before, we are bringing graph machine learning into Blender. This is based on a graph machine learning engine called DGL, which is based on PyTorch. And I'm writing all the nodes for it that will allow you to run graph machine learning on topologic graphs. Also on other graphs. I mean, it doesn't have to be topologic. Anything that is represented in graph can be loaded and you can train it and start predicting. So this is the world of Topologic. I tweeted this a couple of days ago. Basically, it shows you what Topologic has been connected to since 2019 till now, 2022. And it's really like, it blows my mind that we have been able to connect it to all these pieces of software. So we output, for example, to HBJSON, which is the new format for Honeybee for energy analysis. We have a full topologic energy module that can analyze the energy performance of your building using OpenStudio and Energy Plus and shows the color coding inside Blender. We're connecting it to FreeCAD. We've connected it to Spatial recently, which gives you a nice pipe and translation of objects, whether it's coming from Revit or ArchiCAD, wherever it's coming from, through Spatial, we can receive and send objects. And all of these things, Blender, Revit, Rhino, Neo4j, TestFit, HomeMaker, BIM to BIM, all of that is available.
Yeah, this is impressive. Very, very nice work.
Yeah, so that's really where we are with this. What I would encourage you is, go to our GitHub. You'll find it on github.com/WassimJ. Download Topologic's workshop. As I said, it's a one-click install.
Now, I want to understand something like the iPro company or ePro company in Germany use that. If there would be other companies willing to do that, how difficult would it be and why should they try it?
Sure. They would try it because it will give them unique capabilities that they don't have currently. Why would you download a piece of software? If Topologic was, let's say, another instance of a different piece of software, just simply made on Blender rather than Grasshopper or Dynamo, I would say there is no real value to it. But Topologic is so unique that it allows you to think differently about what you're doing in terms of your design process and allows you to solve unique problems. Now, sometimes there are other pieces of software that do energy analysis, and of course, you can use Honeybee and Ladybug, which are the main tools. But once you start using Topologic for its topology and information, then it is easier to do energy analysis and stay within Topologic rather than translate it to something else and move out. The other thing is it's very low risk. It's free, it's available, it's open source. Your engineers and if you have a computational team, can take a look at the code and make sure that it's verified. So nothing is a black box, everything is available. And if it works, you haven't really invested any money in buying it. You can just simply use it. And if it's useful, you can keep using it. And also, I want to say one more thing, because people say, big companies, they need paid software and they don't do open source. Because we are connected to Revit and Blender, etc., you can always, your data is never locked in with Topologic. You can always take your data and move it out, to Revit or to Rhino or anything else you want, and you can decide to stop using it and just simply you'll never lose your data. So there's really very, very low risk in using it.
Isn't that complicated to move the data from Topologic into the model in Revit, for example?
Not at all, because we are using, for example, Spatial will make sure that the data is moved, without any loss. If you do the correct schema and you do your units, the data can be moved without any data loss.
Yeah.
Plus, of course, if you are in Blender, you can save as and use your file format in any way you want, or you can, output to BReps, which are industry standard. Open Cascade BReps can be loaded in FreeCAD into different pieces of software.
Yeah. And what is the phase of the project? Is exactly in early design, is best to use it before starting to model the BIM model, right?
Yeah, I think so. I think it is conceptual design. It allows you to go or to bridge between conceptual design and design development. A lot of people ask for, can Topologic take BIM models, simplify them and make them into energy models so that we can do analysis? There have been some success in that, but unfortunately, this is the wrong way to go about it. You should not have to wait until you have built a very complicated BIM model in order to do energy analysis. Like if you're doing energy analysis at that phase, you're doing it probably as lip service, like to say that we've done it, but it's not going to change your design. So we want to change the mindset. We want people to build these very simple conceptual models that are built very, very quickly, actually. Do energy analysis, do all sorts of analysis, get the information, and then once you have decided, how your design is going to be, then you can move and make them into a BIM model.
Yeah, that makes sense. What are the future plans for this platform?
Oh, I have so many plans.
The nearest future plans, let's say.
The nearest future plans. Topologic needs help, needs resources, obviously, like any other open source project. Yeah, it needs community help. So if anybody is listening to this, we have a Patreon page. Go ahead and donate. But also, you can contribute by testing the software and reporting bugs, right? Like any software, it probably will have bugs and limitations, or suggest ways to improve it. So you can contribute not just financially, but just simply by using the software. One of the main goals of us as in academia is to have something called impact. So we would like to see that what we are doing as research has an impact on industry. So if you are a company, architectural company, and you're listening to this, try it out and then get in touch and tell us, here's how Topologic helped us. Maybe we'll ask you for a one-page letter to describe what you've done with it. But to go back to your question, I have a few things that we need to do. It needs better documentation, definitely, because we've been developing it so fast. The documentation has lagged, so we need to do that. We need to update the videos that we have on YouTube. I have a YouTube channel with a lot of videos that included. In most cases, it's the same, it works, but sometimes I have updated the nodes, so it wouldn't be exactly the same node, so we need to update those things.
Yeah.
And at a certain point, as I said, it could be that Topologic is free and open source, but somebody else can write domain-specific software on top of it, and they might want to sell that. And in that case, they can talk to us and come up with an agreement where Topologic is free and open source. We have a lot of functionality, but somebody might want to even extract more value out of it.
Yeah.
That would be really fantastic, because that will give us resources to develop the foundation even more.
Yeah, but regarding the foundation, do you feel that there are any areas that you would like to improve?
I think yes. I mean, obviously, performance and performance bottlenecks. I know where the cobwebs are, and if I had more resources and more time, I would like to refactor the software, fine-tune it. We need probably some professional help to look at the code and say, you know what, you could modernize the code, you can fine-tune it. A lot of the code obviously has grown out of a research setting. So when you move to a commercial setting or something that is more robust commercially, you would want to fine-tune it and improve performance like everything else.
Yeah, that makes sense. You mentioned regarding how people can help get involved to the project by donating or reviewing it, trying it, and so on. But there are also maybe coders or programmers who could contribute also via code, right? Developing issues and so on, right? Features. But regarding this, do you need to be a C++ programmer, or it is possible to develop using Python as well?
Right. So it's both. So both software bases are on GitHub, and you can definitely do a pull request and suggest, bug fixes or new features or whatever have you. You can also fork the software. So if you are a C++ developer, definitely take a look at the C++ code, which is the base layer, the bottom layer, and you can improve that. If you are a Python coder, take a look at Topologic's Spatial, which is the Python layer on top of it, and you can suggest improvements to that as well. The nice thing about this is that you can also write new nodes in Spatial. Let's say you have a Python library that you would like to integrate with Topologic. You can write a whole set of new nodes and propose them to us, and we will include them with Topologic. I mean, right now we are connecting to, as I said, Neo4j through Py2Neo. We're connected to NumPy and SciPy and DGL, and PyTorch. All of these are Python libraries that we wrote interfaces to and integrated them with Topologic. So if somebody has their favorite Python library and they think, Topologic could have a good synergy with it, propose it.
Awesome. How can somebody reach out to you if they want to contact you?
info@topologic.app. That's if you are talking about Topologic, just email it. Definitely follow me on Twitter, Topologic BIM, It's called Topologic BIM. We have a really good following on that, or on LinkedIn, but I'm more active on Twitter. Or find me at Cardiff University. It's jabiw@cardiff.ac.uk, which is my official Cardiff University email.
Awesome, Wassim. Thank you for stepping by. It was very nice to talk to you.
Same here. Thank you for inviting me.
I wish you all the best.
Thanks.